So welcome back guys. In this lecture, this is lecture number 9. Okay. I'm going to a different format. So the steady stater in general we have a limit s tends to 0 s of r of s by 1 plus g of s h of s. So actually my steady state error is generally depending upon what our system g of s and the feedback element h of s and r of s. Okay, so we have r of s, we have different types of inputs. Let us say that is step input, ramp input, and parabolic, and we have to know about this thing. So it is g of s, that is type of the system. Okay, so what is that means? So in general, the type of the system, the representations of the system transfer function is different. So in general, we'll have so transfer function t of s, closed loop transfer function is what c of s by r of s equal to g of s by 1 plus g of s h of s. Okay, so g of s h of s, so we have here, so in general the transfer function t of s can be represented as some k dash, say let us say s plus z1, s plus z2, s plus z3 up to so on s plus zn by s plus p1, s plus p2, s plus p3 to so on to s plus pn. Okay, so here the z1 z2 are said to be poles of the system, zeros of the system, and this is z1 z2 z3 and p1 p2 p3 so on up to poles. So if I want to find the order of the system, so multiple of all these terms, so if you have 3 poles, so we have a 3 power s thing. So the system can be write like this: t of s can be written as some b naught into s power m plus b1 into s power m minus 1 up to so on s power s pm bn by a naught into s power n plus a1 s power n minus 1 to so on into s plus an. Okay, now the order of the system means what I say is it is a exponential term, the power of this s term. Okay, for this system. Okay, so that means the order is nth order, right? Now this system, if I write in time constant form, so what is that time constant? That means taking z terms all at once and representing this system. If I write some t of s equal to k into, so I'm making 1 plus st form. So I'm writing 1 plus st form. This can be written as 1 by t1s, 1 plus t2 of s, so on up to by some s power j into 1 plus ta of s, 1 plus tb of s. Okay, so p, I'm taking p as a common, so I'm taking out p, so z1, so on up to, that means what this z s of j indicates. So if this is in this, we have no poles in the origin, so it means there is no poles in the origin. All poles are located in left side of the origin, but here what I see is there is a pole in the origin. So j is from 0 to 1 to up to so on infinity. Okay, if j equal to 0 means there is no pole in the origin, this is the function it comes. If j equal to 1 means there is one pole in the origin. Okay, if j equal to 2 means there is 2 poles in the origin. Okay, now the type of the system okay, says that number of poles located at the origin. Okay, so the type of the system says that number of poles located at the origin. Okay, so that is the about now at this junction I want to give some clarity. So what is the difference between order and type? So let us say I'm having a g of s, my main system, as a by s into some a plus a. By looking at this, what I say is the type of the system is having one pole at 0 is 1, and the order means some second order. Okay, now I'm making this system with g of s, okay, and I'm including some h of s, okay, feedback system. Now what happens is RCS. So C by R equal to what? G of s 1 plus G of s into H of s. Now I'm taking, let us take H of s as unity feedback. Now what happens? G of s by 1 plus G of s into 1. Now substituting that a by s into s plus a, so 1 plus a by s into s plus a, and further I'll get a by s square plus as plus a. Okay, so I obtained c by r like this. So another transfer function I got, so a by s square plus as plus a. This is what we call is closed loop transfer function. Closed loop transfer function. Now what is another transfer function is open loop transfer function. So what is that open loop transfer function means? So this is open loop transfer function. So that is g of s, if you're having any loop, now feedback is 1, so it is h of s. So this is called open loop transfer function. So g of s and h of s is called open loop transfer function, and the closed loop transfer function is this one. So g of s by 1 plus g of s h of s. So what I'm saying is in open loop transfer function, what we have is a by s into s plus a. Here we can define the type of system. We can know the type of this system. Okay, but in here closed loop system we can know the order of this system. Okay, so we can't find the correct exact rules here, so there's the thing we need to understand. So while coming to if we give some closed loop system, so we can get the roots of s. So what are the roots we obtain for second order function is s minus 1 and s plus 2. There is will be no type of the system, so we can't find number of poles at the origin, and for the second order system, and simply with open loop transfer function we can know the type of the system, but for the closed loop means we know the order of the system only. Okay, you have to keep in that mind. Now let us continue the topic, that is with the type of the system what I said before, and having different inputs, that is step input, ramp input. We have few things. We have to analyze the steady state error. So that means analyzing steady state error. So I'm simply, instead of writing all the steady state error, I just simply write ESS. ESS indicates the steady state error. Steady state error with different inputs. Okay, with different inputs for different type of system. Okay, so this can be done like this. So initially I go with a different single input. For step input, my input is step input, R of s is a by s, and this is g of a system, open loop system. So g of closed g open loop closed system, g of s h of s, and the type I'm going to describe type 0 for type 1 for type 2. Okay, so with step input I am analyzing the type 0, type 1 and type 2. Let us take type 0 system. So I am writing the open loop system as some k into 1 plus t1 of s plus 1 plus t2 of s, so on, by 1 plus ta of s or 1 plus tb of s and so on up to. Okay, so now we know that for step input, so what is the coefficient we have? Proportional position error coefficient, that is kp is equal to limit s tends to 0. So limit s tends to 0, g of s, h of s. So if you substitute s tends to 0 here, what I'll getting, so the whole s terms will get cancelled, this whole term will get cancelled and we'll end up with k value. So that kp is k. Now if you get kp, the steady state error for the step input, what we have is step input with the finite magnitude. So let us say a is a magnitude. So a by 1 plus kp. Okay, so substitute this kp here, a by 1 plus k. So what is this indicates? I am getting the steady state error for this like this. For step input, I am getting the steady state error, that error is a by 1 plus k if the system is overdamp. If my system is underdamp, I'll get like this, and this error is a by 1 plus k. Okay, so the conclusion part is, for the step input, if the type is 0, we are earning error coefficient is what? A by 1 plus k. Now coming to type 2 system, type 1 system. For type 1 system, we have g of s, h of s. We just include one origin here, t1 of s and 1 plus t2 of s by s into 1 plus t2 of some ta of s and 1 plus tb of s. Now here for the step input, now what is the coefficient we have? Kp is my coefficient. So what is the kp in general? I am having limit s tends to 0, g of s, h of s. Okay, now substitute. So in the substitute this term here, so is making s equal to 0. What is the kp I will have? If you substitute s equal to 0 in this term, so what is the kp I'm having? So the kp I'm get is some 1 by 0, that means infinite. If my kp is infinite, what is the steady state error I'm getting? 1 by a by 1 plus kp. So substitute kp here, a by 1 plus infinite. So 1 plus infinite is also infinite. So a by infinite is equal to 0. So the steady state error is 0. Why my god? It means if my step input is, for the input is step input, for the type 1 system, I will get no error. That means no error if my system is damping. Okay, if my system is overdamped, underdamped, again my response is what? So close to 0. There is no error. So for the system to get no error, the type 1 system, if you give in step input, there will be no error. Now for again type 2 system, again what happens? G of s, h of s equal to k by s square. So type 2 means we include 2 origin. So I know that now you predicted the answer already. Okay, so 1 plus tb of s. So now kp equal to what? Limit s tends to 0, g of s, h of s. Now substitute s tends to 0 in this term. So what you'll get again? The value of kp is 0, 1 by 0. So again the e of s equal to a by 1 plus kp. So a by infinite, that is 0. Again for the type 2 also, again that means if the type of the system is increases from 0 to n, if the input is step input, for type 0 only some finite error, for type 1 to infinite it is giving error is 0. Okay, this is our step input. Now coming to the ramp input. So my input is now ramp input. Okay, and I analyze the system for type 0, type 1 and type 2. Okay, so the input is ramp input for the open loop system, that is g of s h of s. So I'm having g of s h of s as so type 0 system means k into 1 plus t1 of s and 1 plus t2 of s by 1 plus ta of s, so 1 plus tb of s. So for the ramp input, what is the quotient I'm having? That is kv is my quotient. So the limit s tends to 0, what is the kv means? S into g of s h of s. Now what happens here? Substitute this value here. Okay, substituting that value here. So substituting this s equal to 0 here for the type 0 system. So what I'm having? So again what? So if substitute here limit s tends to 0, s into some k into 1 plus t1 of s, so 1 plus t2 of s, 1 plus ta of s, 1 plus tb of s. Directly you assist substituting multiplication of whole term with 0, so I'll get kv equal to 0. Now if my step input, if the input is kv, for the error quotient kv, we have a steady state error is what? A by kv. So value is 0, so error is infinite. So that is a huge mistake, huge error I got. Error is getting infinite. What is this indicates? So if my system is underdamped, if my system is overdamped for the ramp input, for the system is ramp input, and the response now I'll get is, so I should actually, the response should be in relation with this, but for the overdamped system the response is getting some infinite. That means it do not end up anywhere. So the error is between this. Error means what? The desired response and the actual response. The actual response is getting somewhere, so the error is infinite. Okay, for this overdamped system, if the system is underdamped, now what happens? Generally my response should be settled somewhere here, but the response I will get like this. Okay, the error is what? Desired response is what here, but it is going somewhere, so the error is infinite. Okay, the similar passion. So type, this is about type 1 system, type 0 system, type 0. Now for type 1, what we will have is, so g of s h of s k by 1 plus k1 of s and 1 plus t2 of s by s into 1 plus ta of s and 1 plus tb of s. Now again having there for a ramp input, the Polish velocity error quotient, so limit of s tends to 0, k by 1 plus t1 of s, 1 plus t2 of s, s into s by 1 plus ta of s. So this s get cancelled, substituting this empty here. So kv is some constant k. Okay, now we are getting answer. That means the error quotient with the velocity error is a by kv. Substitute here. Now I am getting error some finite value. So I am getting some finite value means if the ramp input, so the if my system is overdamped system, so I'll having end up the response here. So the with error quotient of a by k. If the system is overdamped system, underdamped system, the response, this is the desired response, and the response I'll obtain like this. So the error is k by a. This is about type 1 system. Now coming to type 0, type 2. So g of s, h of s will be equal to k1 t1 of s plus 1 plus t2 of s by s square into 1 by ta of s 1 plus tb of s. Okay. Now kv equal to what? Limit s tends to 0, s into g of s, h of s. If we substitute this here, so we'll end up with s value in denominator. If you substitute this whole term with this s get cancelled. So this kv value will be equal to 1 by 0, that is infinite. Then the error coefficient, the steady state error, if I am having error coefficient a by kv, so the error is infinity. So I am getting what? In 0, sorry. Error coefficient is 0. Steady state error is 0. So what does this mean? For type 2 system, okay, so if this is the desired system, desired response, I will get error 0, okay, for the overdamped system. Now if the underdamped, so for the overdamped system, if my system is underdamped, now what I'll get the value response. So the error is 0. Steady state error is 0 for type 2 system. So now again conclusion is, if the type of the system is increasing, for type 0 error is infinite, for type 1 error is finite, and for type 2 in n the error is 0. Here when type 0 system, type for a ramp input, sorry, for so for step input, for the step input, type 0 is finite value, and after that we'll having error is 0. For ramp input, type 1 is finite value, sorry, type 1 is error is infinite, but type 1 is finite value, and type 2 to from type 2 to n the error is 0 for which input? For ramp input. Okay, this is the conclusion you need to know. Now moving to another signal, that is parabolic input. Okay, so we'll move. Now for parabolic input,